All right, let's dive right into this explainer. We've all absolutely been there, right? Staring at that blinking light on a home or office printer, just trying to get a simple document to print over the wireless network, and the machine stubbornly refuses to connect. It can feel incredibly frustrating. But today, we're going to demystify these devices. We're going on a journey to outline how to work almost any printing machine, all the way from standard office desktops up to massive industrial presses.
Here is our roadmap for today. 1. Setting up office printers. 2. The laser printing process. 3. Essential printer maintenance. 4. Navigating 3D printers. And 5. Industrial and specialty presses. We're taking a straight shot from your basic home Wi-Fi setups to the fascinating physics of laser printing, right into 3D printer calibration, and finally arriving at the heavy-duty world of industrial screen printing and rotary presses.
So, Section 1, Setting up Office Printers. Let's lay the foundation for standard 2D office printing, because obviously before any ink hits the page, you've got to get your machine talking to your network.
Getting connected really boils down to one of two simple methods. You can either use your printer's screen to enter the SSID, which, by the way, is literally just the technical term for your Wi-Fi network's name, along with your password, or you can just use the WPS button. If you press the WPS button on your router to auto-detect new devices, and then hit the matching button on your printer, the two will find each other and lock in a secure connection automatically. Super easy.
But what if your printer keeps dropping off the network every single day? Well, that usually happens because your router keeps assigning it a new random IP address. To stop those annoying everyday drops, you can just lock in a manual IP address. On a lot of standard office machines, you literally just enter a specific passcode into the admin setup menu. Often, it's as simple as typing 6 nines in a row. Once you're in there, navigate to Network Setup and flip the IP address from auto to manual. Boom, the address is permanently fixed, and your computer will always know exactly where to find it.
Moving right along to Section 2, the laser printing process. This is where things get really fascinating because we get to see the actual science of how these machines put ink and toner onto paper. It's not just spraying liquid, it's this incredible dance of static electricity and light. The laser printing process actually happens in 7 distinct steps. The first 3 stages are basically a relay race of preparation. First up is processing, where the printer's brain translates your digital file into a data map it can understand. Next is cleaning. A physical scraper blade and electrostatic lamps clean the photosensitive drum inside, wiping it completely clean like a chalkboard. Third is charging, where a corona wire applies a nice, uniform negative static charge right across that newly cleaned drum. Then, the actual magic happens. Step 4 is exposing. A laser beam precisely scans across the drum, removing that negative charge exactly where your image should be, basically drawing an invisible picture. Step 5 is developing. Negatively charged plastic toner particles are drawn only to those exposed areas. Step 6 is transferring. Your paper gets a strong positive charge, which magnetically pulls the toner off the drum and right onto the page. And finally, step 7 is fusing, where heat and pressure rollers literally melt those plastic particles permanently into the paper fibers so they don't smudge. All right, Section 3, essential printer maintenance. Even the most amazing laser process will totally fail if you don't maintain the hardware. So let's look at how proper upkeep builds the foundation for sharp prints. The absolute most common task you're going to face is replacing toner. But listen, when your machine gives you that first low toner warning, do not change it yet. You're just throwing money away. Wait for the second prompt that tells you it's completely empty. Once it's truly empty, select the color on the control panel and wait for the internal cover to pop open automatically. Seriously, never force it. Take your new cartridge, gently tilt and shake it about 10 times to loosen up the powder inside, twist off that red protective cap, and slide it firmly right into place. So, we've seen how digital files become flat documents. But how do we build upward? How exactly do you translate a digital file into physical plastic?
That brings us to Section 4, Navigating 3D printers. We're going to walk through the specific workflows of 3D printing now, using standard entry-level machines like the Ender 3 to understand this entirely new set of physical rules.
Just like your 2D printer needs a driver, a 3D printer needs what we call a slicer. This software takes a 3D model and slices it into hundreds of flat, 2-dimensional layers, outputting a language called G-code. You can think of G-code just like plotting X and Y coordinates on a graph from middle school math, but with one crucial addition. It adds a vertical Z-axis to build height, plus detailed measurements that tell the extruder exactly how much plastic to push out at any given millimeter.
Let's look at how this workflow actually plays out in real time. You start by grabbing your 3D model, which is usually an STL file. Within about 5 minutes, you run it through your slicer software to generate that G-code. At the 10-minute mark, you're standing at the machine, preheating the nozzle on the bed so the plastic will actually melt and stick. And by 15 minutes, if your setup is perfectly dialed in, you're watching that crucial first layer of plastic go down. Truly, everything rests on that first layer.
And that brings us to the most critical point: getting the right amount of bed squish. This is called bed leveling, and it honestly trips up almost all new users. If your nozzle is too far away from the heated bed, the plastic doesn't squish. You get these massive gaps between your lines, and the print just peels right off into a messy ball of plastic spaghetti. But if you're too close, the plastic has literally nowhere to go. It squeezes out sideways, creating these ugly vertical ridges, or the layer gets so incredibly thin it turns translucent and is basically impossible to scrape off later. To achieve the perfect squish, that absolute Goldilocks zone, you actually use a wonderfully low-tech tool, just an ordinary piece of office paper. You move the heated nozzle to each of the 4 corners of the bed, slide the paper underneath, and adjust the leveling wheels until you feel just a little bit of friction pinching the paper. Do this around all 4 corners twice, and your first layer is going to be absolutely flawless.
All right, Section 5, Industrial and Specialty Presses. We are finally leaving the office desktop and the hobbyist workbench behind to scale up and look at the massive speed and precision of industrial presses.
Now, in the world of garment screen printing, precision is just as vital as it is in 3D printing. A key setting here is off contact. That's the intentional physical gap between the ink screen and the shirt platen sitting below it, which is standardly set at 1/16 of an inch. A great trick to ensure proper off contact is just taping a standard quarter to the top of the screen to check the height. This tiny gap is absolutely crucial because it allows the screen mesh to instantly pop off the shirt the second the squeegee passes, leaving a crisp, clean layer of ink without any smudging.
And when you're printing multiple colors on a single shirt, they have to line up perfectly. We call this registration. Professional presses use X and Y micro adjustment knobs for this. Before you ever think about putting sticky ink into the screens, you have to zero out these X and Y micros to their starting markers. Once they're locked in, you make these tiny millimeter adjustments on a test print, using the Y micros to rotate the screen or move it up and down, and the X micro to move it left and right until your colors are perfectly registered. While modern screen printing is precise, large-scale commercial printing relies on a piece of technology that actually dates all the way back to 1843. That is the exact year Richard March Hoe revolutionized mass production by inventing the rotary printing press. Before 1843, printing was done entirely on flatbeds, stamping just one single sheet at a time. But by replacing those flatbeds with continuous rolls of material feeding through rotating cylindrical plates, rotary presses unlocked blazing high speeds. Today, this exact continuous cylinder mechanism is what allows the global manufacturing industry to pump out vast quantities of newspapers, labels, and modern packaging in the blink of an eye. So, what should you really take away from this explainer? It's that despite the massive leaps in technology, from static electricity in a laser printer to melting plastic on an Ender 3, all the way to the heavy iron of a massive rotary press, the secret to a perfect print always lies in your careful setup. It is all about leveling the bed, zeroing the micros, and setting that IP address. So I'll leave you with this thought to chew on. If the fundamentals of physical precision and careful preparation have stayed exactly the same for nearly 2 centuries, what will the printing presses of the next 100 years look like? And will you be ready to calibrate them?